Alright, so here's problem number 1 on page 10. It's saying a pumpkin tossing contest is held each year in Morton, Illinois, where people compete to see whose catapult will launch pumpkins the farthest distance. The table below includes data for one of the winning catapults from the 2018 contest. Okay. The table shows the horizontal distance the pumpkin traveled when launched at different angles. Okay, so here's my data. Enter the data into the calculator table and look at the scatter plots. Find the best fitting quadratic model. So when it says a quadratic model right here, this is your this is how you know that you're going to do a quadratic regression, okay? Using the quadratic regression feature. So like we're going to put this in decimals and we're going to look for A equals, B equals, and then C equals, and then we're going to write that into our function here. So we can say y or f of x, ax squared, we're going to plug in the a here, plus bx plus c. So to do that in decimals, we're going to plug in the table. Okay, so we're going to do, here's my data, so I'm going to press the plus button right here, plug in a table. So we're going to plug in all these numbers. So 20 goes to, oh, sorry, hold on. Okay, so we have 20 goes to 372. We're just going to plug in all these numbers, okay? Okay, so here's my table, and if let me just maximize it and show you there's nothing because look at how big the y values are. So I'm going usually I start by pressing the home button, and then just if you zoom out, there you go. There are my data, and you can kind of see a parabola. I predict that my a is going to be negative because look, it's kind of pointing down, and it just looks like a quadratic function. So to find the quadratic model or the equation, so we're going to type y1 regressed, so we're going to press regressed by ax1, so ax1 squared plus bx, so bx, so yep, x1 plus c. Okay, so there it is, and look, it is a good match. It's a 99%, almost close to a perfect match. Okay, so there's that, and then here are my numbers. So a is equal to negative 0.5, no, I mean negative, oops, I'll just write it down here. So a is equal to negative 0.26, b is equal to 22.6, and then c is equal to 23.0. So we just plug those in here. So a is negative 0.26x squared, and then b is 22.6x, and then c is 23.0. Okay, oops, sorry. But anyway, all I did was just plug it into my quadratic form. Okay, and the second part of the question is saying, use the model to predict the distance that a pumpkin would travel launched at 55. So basically what it's asking is, so I'm going to rewrite this as a function. So I'm going to change the y to f of x. And so basically what it's asking me to do is plug in 55 for my x. So we have here negative 0.26, x is 55, squared plus 22.6x, and then x is 55 plus 23.0. So I just need to, I'm just going to put all that in Desmos. I mean, if you want to, since you already have it here, you can kind of find it on your graph. You want your x coordinate right here. Right now the x coordinate is 77.7. So if you want to kind of like drag it up to 55 and find your answer, but it's kind of hard to really do that unless you like zoom it in and then look at 55. So right now, there it is. 55 is 474.736. The moment I let go of the mouse, it's going to disappear. Okay, so 474.736. 474.736. So that is my answer. But another, if that's too like not good, you can always just plug it in Desmos. So you can just do negative 0.26 parentheses 55 squared plus 22.6, and then you're going to plug in 55 plus 23.0. That should match. Well, okay, so I would take this one, the one that I took from my graph, more than this one, because I kind of cut off the numbers, right? I rounded them off, but the model that we had here, so like earlier, this is like more of an exact value. Let me just show you one last, probably a little better way. So you're saying that, what is it when x equals 55? Okay, so if you put x equals 55, what Desmos does is it draws a vertical line for you. Let me do that again. So if you go to the next line and you put x equals 55, it draws a vertical line, and then you can just see where they intersect. And they intersect here at 474.736. This is probably the best way to do it. Okay.